Welcome back, Algebra 2. It's Mr. Lamb again. Here is the third section, Unit 8, Radicals and the Quadratic Formula. As we take a look at this, the first one is to simplify the square root of 64 x to the 10, y to the 6, z to the 2. And let me show you, I'm going to try to use the calculator as much as possible to show you some different techniques for solving some of these things. I know this one right off the get-go looks pretty easy with it being the square root of 64. We all pretty much know that. But what I want to take a look at is I want to show you in the calculator how I simplify radicals. So I simplify radicals by taking the numbers, so in this case 64, and I want to divide it by x raised to whatever my index. So this is a square root, so I'll divide by x squared. If it's a cube root, I'll divide by x cubed. And when I look at the table, right, the table of values, you'll see 8, and then in y1 you'll see 1. That means that is 8 radical 1. Another way you could write this is 4 radical 4. Another way you could write this is 2 radical 16. You could write 1 radical 64. So in the x column, that will give you the number outside of the radical, and on the right side, it'll give you the number inside of the radical. So when I want to simplify radical 64, I can pull an 8 out, and it'll leave a 1 inside. So my radical here, I can pull an 8 out, and it'll leave a 1 inside. So I'm not even going to write the 1. But there is a 1 inside. And then x to the 10, since this is square root, I'm going to divide 10 by 2 and figure out how many times it evenly goes in. So 5, so x to the 5, and there would be no leftovers. There'd be no leftovers there. Y to the 6, so if I do 6 divided by 2, that's 3. And z to the second, 2 divided by 2 is z to the 1. And then you'll notice that I have not had anything left to put in the radical, so I can just take the radical off. There would be nothing left for that radical. The simplification is 8, x to the 5th, y to the 3rd, z. As I look at 15, I need to square root 24, m to the 7, p to the 4. So again, let me put this will be what's left over. And I'll save the 24 for the end this time. Let's do the m's first. So m to the 7. So when I do 7 divided by 2, I get a decimal. So I get 3.5, which means I can take 3 of them out. But there will be one of those left, because 3 times 2 is 6. So since there's one m left, I'll put it inside. P to the 4, 4 divided by 2 is 2. So p squared is outside. And now I have to find for 24. We'll go back. And we'll go y equals, and we'll do 24 divided by x squared. Look at the table. So I see 1 radical 24, 2 radical 6, and then I see 3 and 2.66, so that wouldn't work. And then I have a 1.5, that wouldn't work. And then after that, I'm decimals that are smaller than 1. So once you get below 1, nothing else is going to work. Those decimals will just keep getting smaller. So 2 and 6 is my ticket. So 2 is the outside, 6 is the inside. So 2 is on the outside, and 6 is on the inside. As we look at question 16, you'll now see that we're dealing with a cube root. So let me deal with, first of all, I like to do my variables first. So I have a to the 4th. So if I divide 4 by 3, I get 1 and a decimal. So I can only take out 1a. So if I pulled out 1, that's actually 3 of them. That's an a cubed that comes out. So there is 1a left inside. And b to the 6, 6 divided by 3 is 2. So I can take out b squared and have nothing left inside my cube root. The next thing is 54. So 54, I have to do the cube root of it. So y equals 54 divided by x cubed, because I want the cube root. I'll get the table. You'll see 1 cube root of 54, 3 cube root of 2, and then I'm to decimals less than 1. So I want 3 outside and 2 inside. So 2 is inside and 3 is outside. So that final answer is 3ab squared, the cube root of 2a. Number 17, I have a fourth root. So 8 to the 9. So how many groups of 4 could you take out? I could take out 2 groups of a. So a squared. That would be 8 of them. So there's 1 left inside. B to the 20. How many groups of 4 could you take out of 20? You can take out 5 groups. And 5 times 4 is 20, so there's none left on the inside. And now I need to do the fourth root of 32. So y equals 32 divided by x to the fourth root. So divide by x to the fourth. 1 fourth root of 32 or 2 fourth root of 2. So that's my answer right there. 2 and 2. So 2 outside, 2 inside. So 2a squared b to the fifth, fourth root of 2a. Number 18 is an exponent properties. If you remember, this 4 can go down to every one of the exponents. And when I do an exponent to an exponent, I multiply those exponents together. So right now, 2 is raised to the first. So 2 to the first to the fourth will be 2 to the fourth. M to the 3 to the 4. So 3 times 4 is 12. So that's m to the 12. And n is to the 6 to the 4. 6 times 4 is 24. And 2 to the fourth. 2 raised to the fourth power is 16. So this is 16 m to the 12th, n to the 24th. Number 19. Number 19, I like to look at this as just try to get things to cancel. So as I look at things that can cancel, I have a 16 on top and an 8 on bottom. They're both divisible by 8. So that's a 1 and a 2. I have 7 x's on top and 5 on the bottom. So if I cancel 5 out of both, I'll have none left on the bottom, and I'll have x to the second left on the top. Y's, I have 2 on the top and 5 on the bottom. If I cancel 2 and 2, I'll have 3 y's left on the bottom. Z's, I have 4 on the top and 1 on the bottom, so I can cancel 1, leaving me 3 on the top. And then I just rewrite my fraction. My top is now 2x squared z to the third, and the bottom is y to the third. Number 20, 150 b to the 0. Well, b to the 0, anything to the 0 power is 1. So 150 times 1 is 150. Make sure anytime you see a 0 power always means 1. Number 21. If you see a negative exponent just means to take this 36x and put it underneath 1 when I raise it to that power. A negative exponent flips it to the opposite side of a fraction, which we know that 36 to the 1/2 and x to the 1/2 so that's 6. So the square root of x, and that is a 1. So 1 over 6 radical x. 22. I see the negative exponent, so the first thing I'll do is I'm going to actually flip the fraction so I can make that a positive. So I'll put b squared on top now. I'll put 3a to the third, c to the 1/2 on the bottom. And now I'll distribute down this outside 2, this one right here. I'll take this and we'll distribute that in. So my b squared is actually b, 2 times 2 is 4. 3 is on the bottom. It has a power of 1 right now, so 1 times 2 is 2. A, 3 times 2 is 6. And C, 1/2 times 2 is 1. And clean up what we can clean up. B to the 4th. 3 squared is 9. A to the 6th, C. Number 23. This is multiplying things with like bases, so I can multiply the numbers together. 6 times 5 is 30. H to the 8 times h to the 1. When multiplying like bases, keep the base, h. Add the exponents. 8 plus 1 is 9. For j's, j to the 3 times j to the 4. Keep the base, j. Add the exponents. 3 plus 4 is 7. So 30, h to the 9, j to the 7. Number 24 says to solve using some square roots. Be sure that we check for extraneous solutions. So when I want to solve a radical problem, anything with a radical in it, I first want to get the radical by itself. So I'm going to first subtract 7 on both sides. So 2 radical x plus 5 equals 13 minus 7 is 6. Now I'll divide both sides by 2. So divide by 2, divide the 6 by 2, I get 3. You can undo a square root by squaring both sides. So when I square the left, I'll get x plus 5. When I square the right, I'll get 9. Subtract 5. X equals 4. I'm actually going to check this by using the calculator. We said that the answer was 4. Okay. So what I'll do is I'm going to say 4 store as my x value. And then I'm going to type in the equation. 2 square root x plus 5 plus 7. If this does not equal 13, it is extraneous. It does equal 13. So this does work. It is not extraneous. When did that color change? That does work. It is not extraneous. Remember, when you have a multiple choice test and it says to solve for x, you could just, instead of doing the algebra, you could just take the calculator and try all 4 answers, save them in your calculator, type that in, and see which one of them works. So make sure that you're being a smart test taker this week as you take your final exam on Monday. Number 25, first thing I'll do is divide both sides by 3. Divide the right side by 3, I get 5. Now I need to square both sides. So square gets rid of the square root. Squaring 5 gives you 25. Multiply both sides by 2 and get x to be 50. I need to check that one. So I need x to be 50. So 50 store for x. Now my calculator knows 50 to be the x. And I have 3, the square root of x over 2. And this thing better equal 15. And it does. So again, it's not extraneous. That one works. Number 26 says state the domain of the radical. Now, thankfully, you're far enough into your Algebra 2 lives that you understand that you can actually take the square root of a negative number. It just doesn't exist in what we call the real numbers. It is an imaginary number. So as I look at finding the domain is talking about in the real number system. So we know that in the real number system that anything inside the square root has to be greater than or equal to 0. So to find the domain, really easy, 6x minus 5, the part inside the radical, has to be greater than or equal to 0. Because we know if it's not, then it's imaginary. So add 5 to both sides, divide by 6 on both sides. So x is greater than or equal to 5 over 6. Don't forget, if you ever have to divide by a negative number, don't forget to flip your inequality to face the other way. Number 27, find the domain again of a radical. That's fine. The radical of this negative 4 minus 2x has to be greater than or equal to 0. Add 4 to both sides. Negative 2x is greater than or equal to 4. Divide by a negative. Switches the sign. Dividing by a negative 2 switches your sign anytime you divide by a negative. 4 divided by negative 2 is negative 2. So x is less than or equal to negative 2. And number 28, solved by using the quadratic formula. Remember, we do have a couple of songs that you can sing to help you remember the quadratic formula. I Like Frosty. Some other girls prefer Pop Goes the Weasel. Whichever one you want to remember, that's fine. I've also provided it for you. But it's a matter of finding a is the number in front of x squared. So in this case, it's 2. B is the number in front of the x. In this case, it's a negative 3. And C is the number without the x. And this is also negative 3. So as I do the quadratic formula, the opposite of b, the opposite of negative 3 is 3, plus or minus the square root of b squared. Negative 3 squared is 9, minus 4 times 2 times negative 3. 4 times 2 is 8, times negative 3 is negative 24. All divided by 2a. 2 times 2 is 4. Subtracting a negative inside the radical, that's like adding a positive. So 9 plus 24 is 33. All divided by 4. The 3 does not simplify. Radical 33 does not simplify. So when I have it all over 4, 3 over 4 is already reduced. And with radical 33 not simplifying at all, that problem is finished. And I believe that brings us to an end of Unit 7. Good luck. Keep studying.